GATE 2017 Civil Engineering Set 2 Question 41. Two plates of 8 mm thickness each are connected by a fillet weld of 6 mm thickness as shown in the figure. The permissible stresses in the plate and the weld are 150 MPa and 110 MPa respectively. Assuming the length of the weld shown in the figure to be the effective length, the permissible load P needs to be found in kilonewtons. The relevant NPTEL reference has been listed. When we talk about the design strength of a fillet weld, it is given by Pw, which is the product of the permissible stress the weld can take into the area of the weld. The permissible stress is given by the ultimate stress divided by √3 into gamma mw, where Fu is the ultimate stress and gamma mw is the safety factor. The area of the weld is the effective length into the throat thickness of the weld. The throat thickness is given by 0.707 times the size of the weld, that is S. But in a welded structure, it also needs to be verified that the plate strength is higher than the weld strength. In case the plate strength is lower than the weld strength, in that case the design strength turns out to be the strength of the plate itself. So the load that the structure can take is the minimum of the welding load and the plate load. In this case we can see that the effective length of the weld is given as 100 plus 50 plus 100, so that would become 250 millimeters. The size of the weld is given here as 6 mm. Converting this to throat thickness using the formula 0.7s, we would get the value as 4.2 millimeters. Now we will find the load that can be taken by the weld. So the weld strength permissible is given by 110 megapascal, and this will be operated with the area of the weld. So Fp is 110 and the area would be the product of Le and the throat thickness. So this would become 110 into 4.2 into 250. The value would turn out to be 115.5 into 10 cube Newton. So this would be 115.5 kilonewton. Now we will check the strength of the plate Pp, which will be the product of the permissible stress that the plate can take into the area of the plate. So here F dash is given as 150 megapascal into the area of the plate. So we will consider this cross section that will suffer the load. So this cross section would be 50 into the thickness of the plate that was given as 8 millimeters. So this value would turn out to be 60,000 newtons, which would be 60 kilonewtons. So as we saw in the previous slide, the load that can be taken by a welded structure is given by the minimum of the plate strength and the weld strength. So in this case the plate strength turned out to be minimum, which is 60 kilonewton. So 60 kilonewton will be the load that the structure can take. So the permissible load P was found out to be 60 kilonewton. The relevant NPTEL reference has been cited.